Hello students, how are you all? Today we are going to see the salient features of valence bond theory. So what is valence bond theory? Based on the valence electron, the bond formation is explained. That's why we are calling valence bond theory. So what are the salient features of valence bond theory? Simply we can say VP theory. VP theory expanded valence bond theory. Okay. So the four features of a valence bond theory. First one, electrons undergoing the combination, that overlapping, having half-filled orbitals. Okay. So half-filled orbitals only undergoing overlap. So it will produce covalent bond. Covalent bond, right? So half-filled orbital undergoing the overlap, which produce covalent bond. Second point, the half-filled orbital undergoing gives overlapping orbitals, that will occupy two electrons, that overlapped or overlapping orbital having two electrons. It will occupy two electrons. The two electrons should be in the opposite spin. Okay. For example, if you take hydrogen molecule want to form, it will have 1s1. Another one hydrogen also will have 1s1. So both will have the overlapping. So after overlapping, what will happen? The two electron from each hydrogen comes, it will occupy in the same orbital with the opposite spin. Okay. Then when we will get strong covalent bond, the strength of the covalent bond depending upon the extent of overlap. So maximum overlap leads to the strong covalent bond. If you want to produce strong covalent bond, you want to make the maximum overlap, because maximum overlap will give the more energy. Then last one, the orbitals undergoing the overlap, that orbitals having some specific direction. The overlap takes place in that particular direction, we will get the strong covalent bond, right? So orbitals having direction in that particular direction, overlap takes place means it will get the strong covalent bond. Okay, these are the four features of valence bond theory. Next we are going to learn about how they are overlapping. Based on the overlap, we will have two types of bond. Orbital overlap. Orbitals only undergoing overlap, right? So that orbital overlap, atomic orbital undergoing overlap, it will produce hybridized orbital. Okay, right? So orbital overlap, atomic orbital undergoing the overlap on the combining orbital having the electrons, it will occupy the region of that overlapped orbital. For example, if you take two spherical orbital like 1s, the 1s may have one electron, another 1s may have one electron for hydrogen. That two electron may present the region of that overlapped orbital. Okay. Then based on that, what will happen? Based on the overlap, we will divide into two. Based on the overlapping, the bond may be two types. What are the two types? One is sigma bond, another one is bi bond. Sigma bi, right? So when we will get sigma bond, when we will get bi bond? S orbital always produces sigma bond. Wherever we are getting the overlapping of s orbital, it will produce sigma bond. right? Why s orbital only producing the sigma bond which is spherical in shape? Okay, because of spherical shape we don't have any particular direction which is not producing any directional overlapping, so any side it may undergo the overlap. That's why it will produce strong bond, that is sigma bond. So it may form ss overlap. One s orbital may overlap with another s orbital, or sp overlap. One s orbital may overlap with other p orbital, but pp orbital will not give s orbital, you may ask. Okay, usually s orbital undergoing the overlap means it will produce sigma bond. Okay, right? Then pp overlap will takes place or not? Yes. For example, px bond orbitals undergoing the overlap, what will happen? It is also takes place in the same direction. The last point we have studied, the px undergoing the overlap in the x-axis means in the same axis which undergoing the overlap means it will produce sigma bond. Suppose px orbitals undergoing the overlap in y-axis means it will produce bi bond. It will produce sigma bond. Are you able to clear? The same axis the orbitals are undergoing means it will produce a sigma bond. In the different axis other than molecular axis, overlap takes place means it will produce bi bond, right? For example, likewise, in the same axis overlap takes place means it will produce sigma bond, right? Otherwise, in the different axis, for example, axis goes like this, but overlap takes place perpendicular to the axis, so that like overlap produce bi bond, right? Then sigma bond also called head-on overlap. See, head to head there is overlap, so we can say head-on overlap, or we can say axial overlap, but this one is called sidewise overlap. Sideway, because the orbital side by side they are overlapping. Bi bond also called sideway overlap. Okay, so based on the overlapping we can have two types of bond. One is sigma bond, wherever the s orbital undergoing the overlap it will produce sigma bond. Otherwise, other than s orbital may produce sigma bond the orbitals in the same axis or molecular axis undergoing the overlap. Okay, other than overlap takes place other than the molecular axis means it will produce pi bond. Now few examples we are going to learn. First one, hydrogen molecule formation. So hydrogen molecule H2, so made up of two hydrogen atom. Hydrogen atom will have each one as one. So you know that s orbital spherical shape for first hydrogen, for second hydrogen. Okay, so H. Now they are going to overlap, which having 1s orbital, which having 1s orbital. If it is overlap means like that hydrogen molecule will form. Now look at the board carefully. Each one electrons which having electron. These two electron will occupy the overlapped region and also opposite spin, right? See, which is not present in the either side. Instead of that, in between, this is called overlapped region. In that region, that electron will be occupied. This is called SS overlapping. Why this is called SS overlapping? Listen, s orbital overlap with another s orbital. Now we will see with the fluorine. How the fluorine molecule is formed? F2. So what is a valence shell electron for fluorine? 1s2. Next 2s2, 2px having 2, 2py having 2, 2pz having 1. So if you draw the structure, we can easily understand. 2s2 having 2 electron. P orbital means which having 3 orbitals. 2 electron in the X, Y also 2, P having 1. Already we know that half filled orbital only undergoing the overlap. Okay, only one half filled, that is belongs to 2pz axis. Okay, 2pz. This is 2pz, 2py, 2px. Okay, orientations like that. Right. Now the 2pz you can draw dumbbell shape. This is 2pz for first fluorine. The second fluorine also will have the same dumbbell shape, 2pz. Now what will happen? It will undergo head-on overlap. See what will be the product. See, first fluorine 2pz, second fluorine order 2pz. Now what will happen? It will produce sigma bond or bi bond. Yes, definitely it will form sigma bond because this is overlapped in the molecular axis, the same axis. If you take the atom first fluorine, second fluorine, they are present the same axis. That axis is called molecular axis. In the molecular axis, overlap takes place, so it will form sigma bond, right? So sigma bond, okay, is also called pp overlap. Why this is called pp overlapping? P orbital overlapped with another p orbital. That's why we can also call the pp overlapping. So next, hydrogen fluoride. So separately we have seen for hydrogen molecule and fluorine. Now hydrogen fluoride, HF, simply write HF. So HF molecule for hydrogen 1s1, for fluorine the same 2s2, 2px2, 2py2, 2pz2. Now what will happen for hydrogen? S means a spherical shape. S orbital always spherical shape. Then we have 2pz, only one electron. This orbital only undergoing the overlap. So one p orbital, that is 2pz, 1. So one spherical, one dumbbell shape. So whenever the s orbital comes, it will form sigma bond. So it will overlap like this, S and 2pz1. So we can say sp overlapping. These two electrons will occupy in the overlapped region. So this overlapping also called S and P. So sp overlapping. Okay. Now all bonds, whether this is sigma bond or bi bond. Okay. So all example you have seen for bi bond. Now we will see one example for sigma bond. You take oxygen molecule O2. So there are two oxygen. For first oxygen, how you write? 1s2, 2s2, 2p4. Sorry. So this is inner cell. So 2s2, 2p4. Again, how will you split? 2s2, 2px1, 2px2, 2py1, 2pz1. So 4 orbital. See, you will learn in 12th. Anyway, I am saying first we have to fill 4 electron in the p orbital. 1, 2, 3. Again, we have to start to fill from the first box. So 2px having 2, remaining having 1 electron, each 1 electron. Now 2 orbitals are ready to overlap because both in the half filled nature. Now 2py, then 2pz also there. Okay, 2px, 2s and all having completely filled, so we need not to touch. So 2py, we can write 2pz. Now for first fluorine, sorry, first oxygen, then next oxygen also same type. 2 orbitals are waiting for overlapping. Oxygen 2, right? 2py, 2pz. Now if you draw the molecular oxygen, what are the orbitals are present in the molecular axis? 2p orbitals only, but 2py perpendicular to the molecular axis. So this 2pz orbital will undergo head-on overlap, these p y orbital undergo sideways overlap. We will get one sigma bond as well as one pi bond. Listen. Okay. Then for another one. So now to pz finished its overlapping, there is two electron. One from first oxygen atom having one electron to pz, second also one. So totally two electron filled. Now what will happen? The sideways overlap. This 2p y orbital also want to overlap, you know, it will overlap like this. Okay, so sideways overlap it will take place. So this bond becoming sigma, this bond becoming bi. That's why if you write oxygen molecule, we will write double bond. First bond is sigma bond, another bond is pi bond. Okay, so one sigma bond, one pi bond, because head-on overlap will form sigma bond. Sideways overlap, perpendicular to the molecular axis overlap means it will form pi bond. Okay, next we are going to learn about hybridization. What do you mean hybridization? Only one example we will see in that. Okay, what do you mean hybridization? See, usually we are learning all the hybridization, that means see, overlapping based on the atomic orbitals. Okay, if there is two atoms in that molecule, we can easily explain. In case of the molecules like beryllium chloride, ammonia, water, methane, CH4, this like having many atoms, even though we have bigger compounds with many atoms participated in that. Okay, so far that we cannot explain all the overlapping and all. And also we can compare, for example, carbon, hydrogen. In the methane, we want to explain for this bond. Carbon having 2px1, 2pxy1, then 2pz0. Hydrogen having 1s1. How will you compare this energy? 2 second cell, that means the energy level is high than that of first one. So because of this problem, all the compounds we cannot explain based on only in the overlapping. That's why we need one more idea, that is nothing but hybridization. HY. So what do you mean hybridization? Intermixing of atomic orbital which produce a new equivalent orbital, that is only called hybrid orbital. That means you may not easily understand. Listen, the same fluorine we can take, just now we have seen, you know, or carbon will take, carbon having this two half-filled orbital, 2py having one, 2px having one, right? So this unfilled or which one is having half filled, it will undergo the intermixing. So one atom, that atomic orbital itself undergoing mixing, and it will produce one equivalent or equal energy with equivalent orbital with equal number of orbital. For example, 2p orbital undergoing mixing means it will give again two equivalent orbital, but that the energy levels are considered equally. That is only called a hybridized orbital. Okay, so simply we can say the atomic orbitals mixed into produce new equivalent orbital. That new orbital is only called hybridized orbital. In that we can split up the electron. Wherever we have the double electron in the single box, we will split up into each one, so it will reduce the repulsive force among the electron. Okay, so because of that the hybridization is more possible to explain easily, right? So again I am explaining what is hybridization. Intermixing of orbital, the atomic orbital itself mixing themselves, it produce equivalent new orbital with the same energy. How much number of orbital undergoing mixing? Equal number of orbital is produced. That produce new equivalent orbitals are called hybridized orbital. Okay, so if you see one example, you can easily understand. First example with sp hybridization, beryllium chloride. Beryllium chloride. Okay, so beryllium chloride means which is a central atom? Beryllium. We must know that central atom only will produce a hybridized orbital. First write the electronic configuration 1s2, 2s2, right? Beryllium atomic number 4. So 1s2, 2s2. So this is inner cell electron. We can leave it. Only outer cell will undergo. So for that we can write in the ground state. Ground state means what? At the ordinary condition. At the ordinary condition, what happened? This 2 is having 2 electron. 1, 2. Is there 2p orbital? No. But is there half filled orbital? No. Without half filled orbital, how it will undergo the overlapping? It cannot undergo the overlapping. So it want to becoming half filled. So you produce the new empty one. Okay. This is named as 2px, 2py, 2pz. But there is no any electron. Then excited state we want to write. It itself produce excited state. How? By shifting this from 2 electron, 1 electron will shift to 2px orientation. So in the excited state, what will happen? The s will carry only 1. The p will carry 1 electron in the first box. 2px will carry 1. Now we got 2 half orbital, half filled orbital. So now these 2 orbital will undergo the mixing. Okay, so it will mix means it will give 2 orbital, 2 orbital mixing. So how many equal orbital will form? 2 orbital. Okay, then how many electrons are there? 2. So each one will take this new equivalent orbital only called hybridized orbital. Okay, now this hybridized orbital will undergo overlapping with this chlorine. Okay, before that one s orbital, one p orbital which undergoes mixing. So we can write sp hybridization. Again I am saying one s orbital and one p orbital is mixed and form these 2 hybridized orbital. So sp hybridization. Now the chlorine, we have 2 chlorine atoms, you know. What is the last electronic configuration? That means valence cell electronic configuration 2s2, 2px2, 2py2, 2pz2, 1. So all the remaining we don't want because already completely filled. So 2pz or 3pz having 1 electron. That 1 electron will give to this sp hybridized orbital. So what will happen? We have 2 chlorine. Each chlorine, first chlorine will give 1 electron. Next chlorine will give. So it will pair the electron. The bond formation will take place. So this we can represent by using the diagram. Right? For beryllium, we have 2 hybridized orbital. What are the 2 hybridized orbital? We can write hybridized orbital for beryllium. Okay, so 2 hybridized orbital, red color. Then first chlorine having 2pz, that is becoming dumbbell shape, you know. So that chlorine having that 2pz orbital. Right? This side also another chlorine. Chlorine 2pz orbital. This is beryllium's hybridized orbital. Now hybridized orbital have 1 electron. This chlorine will give 1 electron. So 2 electron occupied in the hybridized region. The same way beryllium have 1 electron. Chlorine will give. So overlapping. So because of this, linear structure is formed. What is the bond angle? That means angle between this hybridization 180 degree. Okay, so linear structure will form. So this like we can easily explain the hybridization, right? Next, we can take another one hybridization at last. What is that? Boron trifluoride. I forgot to say what is the hybridization? sp hybridization. Now, boron trifluoride sp2 hybridization, right? What do you mean sp2 hybridization? We'll see. Boron 2s2 2p1, right? So we have only one unhybridized. So in the ground state, how will you write? 2s2. Then p orbital will have 3 box, but only in the x we have 1 electron. Y, z. So this is ground state. How will you write for excited state? Excited state, this one of 2s orbital will jump to s. It will go to the, already we have one more will come. Okay, this is excited state. Now what will happen? One s orbital, 2 p orbital will undergo hybridization. So these all three will mix together. It will produce new equivalent orbital. 1, 2, 3. So 3 new orbital will form. That is hybridized orbital. Each one will have 1 electron. Now how many fluorine we have? 3 fluorine. Fluorine also having 2p z orbital with 1 electron. So first fluorine, second fluorine, third fluorine. Each one will give 1 electron. So they will form bond. So how hybridization will take place? 1s 2p orbital. sp2 hybridization will take place, right? So in the diagram we can draw for boron. How many hybridized orbital? 3. How will you draw? Okay, for boron, which having 3 hybridized orbital. If you see your book, that is given the different color like green, right? Then for first fluorine, fluorine having only 1 2pz vacant orbital for overlapping. Okay, for fluorine 2pz orbital. Here also another fluorine. Here also another fluorine. Okay. Now the electron will occupy in this hybridized area. Now listen carefully, which forms like a trigonal. So which present in the same plane. So trigonal planar structure will form. Okay. What hybridization? sp2, 1s and 2p orbital undergone this hybridization. It forms trigonal planar structure. The angle between bonds are 120 angle, right? Remaining we'll see in the next video.